Thank you very much for taking your afternoon and spending time with us to hear a couple of folks talk about artificial intelligence. By way of background, I'm the Senior Director of Product Management on Artificial Intelligence and ChatBots at Oracle. Just a little bit about my background. I've been at Oracle for 9 months. Prior to that, I headed products for a deep learning technology company called Emotient. I helped to commercialize technology that had been in development for 20 years by 7 scientists who founded the company, bringing together cognitive science, computer vision, and machine learning. And what we did was to use the technology to detect how you feel by analyzing your face, using images and videos from any camera. At the end of that experience, we were acquired by Apple, and our technology is part of the iPhone X's Face ID and Animojis features. And prior to that, my entire career has been in product. I started out as a developer, and then I switched to the dark side, got an MBA, and then have been on the business side of product management for the last decade or more, but always hands-on. And so here's an assertion by IDC. This year, 75% of development will include cognitive AI or machine learning functionality in at least one application. I think you can all sense that the massive demand for machine learning talent, the massive, perhaps, hype around all the kinds of machine learning applications and technologies that's being deployed all around us, much more so than the average consumer might realize. But despite that, I think we're still at the very early stages, less than 1% of I think, the vast potential of artificial intelligence. But to kind of level set a bit, right, there doesn't seem to be a standard agreed to definition of what artificial intelligence is. So here's kind of 2 perspectives on that. Dr. Arthur Samuel in 1959 actually coined the term machine learning, and he defined it as the field of study that gives computers the ability to learn without being explicitly programmed. And so that very well sums up the whole field of machine learning. And what blew me away when I was first introduced to machine learning 5 or 6 years ago was that, having been a developer full-time earlier in my career, everything was deterministic. So the notion that an AI machine in software predicts something or makes a decision, and it's very difficult to understand why, because the transparency isn't there. And the transparency isn't there because the complexity of the calculations underneath is so high that you can't understand that without duplicating the math yourself as a human, and that's just not often possible. But then, more broadly, what's the definition of artificial intelligence? Here's my take on it. I think it's the intelligence of machines that replicate and enhance human cognitive, behavioral, and sensory functions. And that's just about everything that we do as human beings, including seeing, hearing, feeling, understanding, speaking, understanding conversation, having conversations, making decisions, predicting, recognizing patterns that we as humans are incapable of, playing games. Those of you who play games, I'm sure you're playing against AI. Driving, we all are aware of Tesla and Uber and all the car companies investing in self-driving cars, and I'm sure you've heard of robots who can walk, not unlike humans and other animals, and so on and so on. Anything that duplicates human cognitive functions and express whether motor and otherwise is really artificial intelligence. And so when I decided to join Oracle, I had this perspective on the artificial intelligence market, because as many of you are aware, oh, by the way, how many of you have started a machine learning or AI course of some type? How many of you? Okay, all right, maybe 20%. 30%. How many of you actually finished completely a course in certification? Okay, about a third of that. All right, so it's a big investment, and oftentimes the math is pretty challenging. But the way I kind of think about artificial intelligence market is this. As you know, many of you know, especially those who have taken machine learning courses, data is king in machine learning, right? You have the data, you can really replicate anybody's algorithm and model. And so from an AI market perspective, the ones that own the data or have access to the data are going to be dominant, right? And so I think about the market in three large segments, right? The folks who get all the marketing attention and the buzz are companies like Google, Facebook, and now Amazon, and lesser known about AI is Walmart. But those companies are using and have vast access to all the data that we have as we use all of their services, right? I often say to folks who ask me about privacy, and I really think privacy is an illusion. It really doesn't exist. You have to be smart about what you're doing online and be aware of all the controls that you have and the policies that are there. But to the extent that you use all these services across all your screens, they really have a lot of data about you. But for them, their two markets are all about advertising because the data that they have is consumer data, right? And so Google and Facebook, their revenue model is advertising. So to the extent they have that data and then can predict and target you with advertisements and offers that are less like spam, but perhaps more according to what you really are interested in that moment, they will be better off as companies in revenue. And then on Amazon and Walmart, they really dominate the commerce transaction. So to the extent they have that data about what you're buying, what you're browsing, what triggers you from browsing to actually buying, all that data, then they can give you offers that are more likely to trigger you to actually conduct the transaction. Yeah, and the whole life cycle, of discovery, trying, and then buying, and then follow-on services and related, products and services based on beyond your initial purchase. So they own the data, right? For Google and Facebook, it's consumer data. For advertising, for Amazon and Walmart, it's commerce data to optimize commerce revenues. But on the enterprise, I really think it's relatively white space. It's really not quite tapped yet. And I think that's the good news for the enterprise players. And for Oracle, we have, I think, tremendous strengths there. Our footprint, public information on our website, we have 450,000 customers, right? Our heritage has been 40 plus years on enterprise software. The database is dominant. But then since then, we have the broadest portfolio of SaaS applications for any function within any enterprise. And so I think, the enterprise is really untapped, less so even than the consumer and commerce markets. And so I think the companies like Oracle are well positioned to really take advantage of that. Okay. Does that make sense? Okay. Now, AI is hard to implement, right? Especially in a commercial business sense, for three main reasons. One is that there just aren't enough PhDs with machine learning type degrees or experience, right? And then second, as those of you who have hands-on experience with machine learning, deep learning, and all the variants, building models is complex, right? You start with a use case, you have to gather training data, you have to iterate, right? Development of the models themselves are non-deterministic. It's a lot of experimentation, unlike traditional software development, where for the most part, unless you're creating brand new things to the world using new algorithms, for the most part, it's pretty predictable, right? Given a set of requirements, some features, you pick your whatever software platform and tools and languages and all that. And for the most part, if you're an experienced developer, you can predict pretty well how long and difficult a particular engineering task is. AI development is not like that. It's not deterministic. It's a big cycle of experimentation. So development complexity is really high. Plus, you need access to, especially if you're working on large data sets and you're doing deep learning, right, with neural nets that have many layers, you need access to high-end GPUs to make the math tenable, right? Otherwise, you'll be waiting decades for an iteration of a calculation, right, of a cycle. And so these are the challenges. Not enough people with the right skills. Building models is hard. And then if you're doing deep learning with tons of data, a lot of high compute capacity you need to have access to. So with that as really the high-level challenges for companies who want to implement, Oracle's approach is the following. We're going to embed AI in our products. We already are. No PhD required. It works seamlessly. It's a part of the product. You don't necessarily even know that it's AI that's helping you predict, sales leads or supply chain optimization decisions or what have you. So we'll embed and continue to embed more and more AI within our applications, right? So no PhD required, no model building required. You have the data. Use the data you have to enhance the models that are already pre-trained in our application. And then for those who are brave enough and have the talent necessary, we'll continue to invest in tools and development environments for those who have teams with the right knowledge and on AI and the tools they need. Will help them build models, with tools and infrastructure. And then we also, like the other players I mentioned on the previous slides, we'll continue to invest in high-performance infrastructure. That means fast networks, high-end GPUs, so that as you're building these complex models, you have the compute capacity to do, to reduce the cycle times in iterating your models. So that's kind of a high-level view of my take on AI and how Oracle kind of thinks about it, right? So my product is the Oracle Intelligent Bots product. It's a platform that allows our enterprise customers to quickly build and deploy chatbots. Okay. And so here's another assertion by another analyst, Gartner. They're asserting that conversational AI first will supersede cloud first and mobile first as the most important high-level imperative for the next 10 years. In the 9 months that I've been at Oracle, I've been speaking to many dozens of customers, and it's pleasantly surprising to me how bold they are in terms of what they plan to do now in the next 5+ years with conversational AI. And so I can confirm this kind of assertion through direct contacts with our customer base. But what's the intuition behind that, right? So from an end user perspective, it's quite simple. It removes friction between you, the end user, and information and transactional and functionality that today are trapped behind 5 million applications across the iOS and Android stores, respectively. Behind complex websites, you have to do a Google search if you want to find certain kind of information, or if you even know which website it is, might be your bank. You have to dig through their website and find the functionality or information you need to get to. So the promise is this, kind of like the HAL 2001 and Star Trek, where you can just utter what you would like and have that system somewhere behind the scenes figure out where the answer is or the functionality is, and then get it for you, right? Rather than do that. Especially relevant if you're driving, right? You don't want to be texting or typing. You want to be able to utter, take me here, take me there, find the nearest, X restaurant ahead of me, not behind me, right, as I'm driving. So that's from an end user perspective. The promise is to remove friction between the user and what they need. But from a business perspective, right, I often say that all value propositions for enterprises have two destinations. They either have to deliver increases in revenues or they have to save money, right? And so through our discussions with customers, some of them have gone live with chatbots. They are beginning to see the financial benefits of deploying chatbots, right, for very specific use cases. But again, like AI and machine learning in general, conversational AI is no less difficult, right, for these reasons, right? if the promise is to remove friction between the user and what they need, then you can't force them down another entry point, download yet another app, go to yet another website. So if you want to do that right, you can't add friction, replace one friction with another. And so you have to support any entry point that the user might be coming in from, whether they're in the car, in the office, in a meeting room, or traveling abroad somewhere, right? And then second is implementation complexity. Many of you have tried, I'm sure, online, the open AI platforms out there. You'll spend an hour building a weather bot, right? But we're talking about enterprise class, enterprise type use cases that deliver real value, that require access to systems of record behind the scenes. And so that's non-trivial. And good news is that we've done that our entire 40 years in existence, Oracle. And then again, don't try this at home. Getting all that AI right, sewing together the whole set of technologies necessary for a platform, a chatbot platform, to understand what the user is saying and extracting from that what they're trying to do, and then convert that to a process that then goes and fetches the data or functionality they need is complex, right? And so given those challenges, our approach therefore is that we're agnostic to the channel. So we want our customers to be able to build chatbots that can come in from any channel, whether it's SMS, Slack, Microsoft Teams, Facebook Messenger, any text, and so on. Any entry point. So deploy chatbots that support your existing entry points for whether it's an enterprise employee or a partner or an end consumer, if you're a consumer retailer, right? And then second is enterprise ready. That's our bread and butter. We got a broadest portfolio of SaaS applications. We've got a cloud, all in the cloud, as well as on-premise, and so we can handle all forms of deployment models, whether it's cloud, on-premise, or some hybrid version of that. And then again, no PhD required. All this stuff works out of the box. Not a whole lot of technical understanding necessary to make it work. And because of the potential complexity of all of this AI stuff, our design goal as a product team is to deliver a time to benefit of 0. That's our aspiration. We're not there. But I can tell you that several of our customers who recently went live in the last few months, they built their bots in 2 weeks, okay? And they deployed it in a couple of more weeks after that. And so that's our goal. Okay? And that means that bringing together pre-built channels, right? Facebook, web, iOS, and all that, so that they can add chatbot functionality to existing entry points that their target end users already use. We provide all the design and setup tools to do it all very quickly. We provide analytics so you understand how your bot is performing against your expectations, where a user is getting hung up, where is it doing well, how can you improve the bot very quickly and iterate quickly as you get more usage, more data. More data means better bots. And so incorporating that in the whole life cycle of your bot is important. And then all the core components that contain business logic and back-end integration. We provide all this in one platform so that you can get up and running quickly. So with that, I'm going to show you what this stuff looks like, from an end user perspective. So I'm just going to use Facebook Messenger as the entry point, right? So I have a couple of chatbots to show you. One is these are 2 prototypes, right? And I hope the demo guys are good to me today. One is a banking bot. So, if you're a customer of Wells Fargo or Bank of America or a technology credit union and so on, you can imagine these companies launching chatbots to serve you as a bank customer. And so maybe you might speak to the bot and say, "What's my balance?" Right? And so the bot takes that utterance, the phrase, and asks you, "You know what, you didn't give me enough information because I know you have 3 kinds of accounts. So which account would you like your balance for?" And so I'll say, checking. Another example might be show my recent credit card purchases. It just shows you the rich media type capability, right? And it shows my transactions in a carousel type format. And then another transaction might be pay the babysitter, right? So maybe you want to conduct payment capabilities. And so I'm going to pay the babysitter from my checking account. But let's say while I'm doing this transaction, so I just started the transaction, right? I forgot how much money I have in my checking account, whether I have enough or not, right? So I'll say, I'll take a sidestep, right? Because human dialogue is nonlinear, right? How many of you actually stay in one thread in a conversation for very, very long, right? So maybe I'll say, how much do I have? How much do I have? Okay, I have enough money to pay the babysitter, and I'll continue with my original transaction. And I'll go on my merry way here after I do that. Okay. Another question you might have for, let's say you open up a new bank account, a checking account, you might wonder, like, how do they calculate your current balance? Because you got stuff coming in, stuff coming out, deposits and so forth, checks outstanding. Maybe you might ask a question like, what's not included in my balance, right? So that's kind of an interesting question, right? So what this particular bot is able to do is, hey, you know what? Do you want to know how the math is done? Kind of like an FAQ type question about the math behind checking or balances? Or do you want to actually check your balance, right? How much money you have, right? And so maybe in this case, I'll view answers. And so it gives related answers, and I can view an answer. Okay? And you can scroll through that. Another functionality that we believe is really important is this, especially for enterprises. Let's say the customer launches a bot, and the bot trips up. The end user's uttering stuff or wants stuff that they can't handle, or maybe the user's frustrated with the bot, right? Our customers would want the bot to hand you over to a human, right? So on the right side of my screen here is a UI of one of Oracle's SaaS products. It's the Service Cloud product. It's a customer service product where a human customer service agent can chat with customers, right? But on the left-hand side, again, is my chat bot. Let's say I say I'm frustrated with this bot. And so the bot says, hey, should I connect you to an agent, or would you like to let me try again? I've had enough of you, so connect me to an agent. Right? And so what's happening is we're connecting to the agent over here, and I get a prompt as a customer service agent, right? And the nice thing is that the agent in this chat window here has full access to the chat history. So the agent's not going to ask you the same questions again, And so, hi, my name is so, I will be assisting. Please give me a moment to look at your account. So they're looking at the history, and maybe the user says, I'd like to know my credit card balance, right? And then the customer service agent gets that. Oh, I'd be happy to help. Actually, the agent knows that the chatbot can help you right away. So I will hand you back to the chatbot, right? And what's nice is this. The agent can actually trigger the bot to answer that question on behalf of the user. And I do that by / balances, right? So the user can then now be helped by the bot. And then the customer service agent needs to remain, at least in this scenario, in contact with the user. They don't need to see their credit card balance. But back in the bot right here, as you can see on my phone, I can now just touch a credit card. Okay. So that's a financial bot demo. I have another demo that's a little bit more AI involved. It's a fictional fashion retailer for consumers. And the scenario is such, I see the folks who speak Chinese are smiling. So the scenario is that this person is going to be attending a wedding. They live in Seattle, but the wedding's in Beijing. And so, but they'd like to buy an interest in buying a dress from a retailer called Z Fashion. But first they want to know, do you ship to China? And it's an FAQ type question, right? So actually this is a real FAQ from one of our retail customers, right? And so, yes. So, and then you might follow up with how long does it take, right? And then another FAQ type, question. Yeah, so, cool. So, okay. I'm planning early enough, so it should get there on time in the worst case scenario. So at this point, I'll segue to maybe looking at products that I can buy. So maybe I'll say going to a wedding, show me something I can wear. And so it comes back with some recommendations. Maybe it has some history, and maybe you like the darker shades dresses, and so I'd like similar ones here. Again, AI here, we're talking about recommendation engine, right? Those of you who are learning about machine learning, so that's another application of machine learning is recommendation engine. But let's say this person looks at the dresses, they don't like any of them, say, I don't like these. So if you don't like these, do you have a photo of something that you might like, right? So this user happens to be a fan of the Devil Wears Prada movie, right? And so they're going to upload a photo from the movie. I'm hoping I selected the correct one here. Okay. Right, and so the bot will receive that image, do image analysis, do object recognition, that there's a dress, and then map metadata in that object to other relevant objects in their product database and provide recommendations, right? And maybe I'll buy that one, okay? And so I'll start the buying process. And this is an example where we're showing you a very effective way to do complex, rich data exchange with the user. Really impossible if this were only in text. You can imagine a chatty. They live in Seattle, but this is a new address, and I'll say Beijing Marriott, right? And I'll confirm that. And then I'll X out of there. I've got my order confirmation, and maybe next thing you want to do is you want to check order status. And we obviously, because we're a global company, we have to support multiple languages. Actually, I don't speak Chinese, so you have to trust me on this. Correct me if my utterance is incorrect, but yeah, so we do that. Maybe the next thing you want to do is actually you want to return an item. You got the dress. How do I return items, right? And so again, it's do you want to learn in general how you return items, or I should do a return? In this case, I'm going to actually do a return. Again, I'll kick off a return process, and I will have a barcode up here, right? And so here, I'm going to take a picture of a barcode. Again, you have access to the capabilities of your device. In this case, let's say I take that photo of a barcode, upload the image, and you can imagine this, being processed and verified and so on. And then what you can also do is provide back to the user once this is processed So I want to return that one, didn't fit me, submit it, and then I get a return label that I can print out, right, attached to the package, return package. So that's the end of the demos. So I'll segue back to the discussion of this, right? So just kind of give you a deeper sense of how this all works behind the scenes. And there are really, 4 main steps here. One is by the way, take a step back. Step 0 is that define your use cases, right? Define the functionality that you want to support in that use case, right? And then you define how the bot should dialogue with the user, right? Really the dialogue flow, we call it, right? How should it respond, the language and so forth that's aligned with the company's brand. So once you have all that decided, right, and that's really a business set of decisions, then you have to figure out, given that target use case, these are target end users, these are the channels that I want to support. Maybe it's Facebook Messenger, maybe it's a web page, insert a chatbot in a web page, or a native iOS app I have today. I want to add a chatbot functionality. And so channel integration. And then to support that use case, using natural language processing terminology, you define intents. Intents are the actions that you want the bot to support. So intent in my financial bot is pet balances, right? So you can check balances as an example. And in defining your intent, you supply to the bot a set of example utterances that you would expect your end users to use to check balances, for example, right? If you have existing real data, that's the best because that reflects true usage. And so the bot will be very good at recognizing what your end users are going to say. And then along with intent, you also have entity, right? And so entity in NLP terminology is are additional information parameters need to fully execute on behalf of the user. So in the case of the financial bot, it's not just check balances, but for what account. So account type is an entity. So once you have the intent identified, the bot through AI, machine learning, natural language processing, check balances, right? And intent checking, then the bot can go off and do its magic, get the information back for you. Okay. And so, high level, we give the customer easy ways to connect to different channels today, right? We allow them to easily define the dialogue flow between the bot and the end user. We build out of the box, provide out of the box ways to connect to any kind of backend, not just oracles, any kind of backend. And then all the magic happens through AI. No PhD required. And I showed you this in the demo, the Z fashion one where you're returning a product and so on, right? Where you really raised the threshold of rich data interaction that a chatbot can actually support without really angering the user and making it unusable. So if it were just text, doing the return, for example, processing, it just wouldn't be a very good chatbot experience. But through instant apps, that makes it much more tenable. And then again, you can't fly a plane without instruments. We give you ways to understand how the bot's doing. What are customers saying? What are their most common utterances? What are the most common intents? We also allow pathing analysis. So a user tends to go down this path for this kind of intent. Maybe they're dead ending, they're bailing in the middle of it. And so we allow you to analyze that and then add missed utterances to the training data right away. And so the bot can be better very quickly. In terms of why we think we're pretty good at this stuff. Although we don't have the mind share around AI, we did our own benchmarking against public data sets and a public report out there. And those of you who have studied machine learning, the F-score is a measure of how well an AI model or machine learning model performs against predicting something, in this case, like intents. We are in the same ballpark and not better than the main ones that are out there, Google, Microsoft, and IBM. We have, we think, a really good dialogue design, very easy to build dialogue flows. We have multimedia, rich, instant app capabilities, right? Much more than you might expect from just your previous understanding of chatbot capabilities. And then, man, we bring everything to the table, out of the box. Design goal being, time to benefit of 0, okay? And so just another key point I want to make is that we're really a horizontal play, meaning we want to build a chatbot platform that supports any use case. And I've seen all kinds of use cases, business to enterprise, business to employee, business to consumer, gaming, marketing, commerce, financial, insurance, field support, field fixing things, manufacturing floor type chatbots, just about anything you can imagine in the enterprise. And again, we're open on the front end, any channel, and we're open on the back end. As long as there's an API that supports the use case, we can connect to it. And so just in summary, our platform, the goal is to enable rapid development of chatbots, one platform in any enterprise type use case, and then very importantly, from an end user perspective, a rich end user experience. Because again, you want to remove friction and provide a delightful, easy to use, seamless experience. And so that's the end of my slides. I can open up to questions. Any questions about AI or anything, enterprise, anything, machine learning? Okay, she's got the mic, so she kind of controls.
So we'll quickly have 10 minutes for Q&A, and then we'll have our second presenter, Karn there, from H2o.
Hey, this is just a question regarding the way you were writing, your queries. It seemed very confined in the way you were declaring maybe like a bank account or what you want to do, like an order. But what if there's there's unstructured data? So what if I am talking about my bank account and booking my travel, etc. How does the AI handle this unstructured data? Is that sure. Still being done, or?
Yeah, again, data is king. So for an intent that you want the bot to support, right, you have to supply example utterances, right? So if you want to book travel, maybe book travel is an intent, but you have to tell the bot these are what you should expect, in terms of what people will say when they want to book travel. So you supply it with training data, right? Maybe a few dozen examples. And then as you get real usage, you'll see in the logs and history and the reports that we supply you, utterances that got hit correctly and utterances that it missed but it shouldn't have. You can quickly add that back to the training data and improve the bot very quickly.
Thank you, Dan. Any other questions?
You mentioned on-the-fly training and improving the models. Could you please describe a little bit more in detail about what goes on in the background to do that, to the extent possible?
In terms of the machine learning that's happening behind you?
Yeah, let's say, something worked and something didn't work, right,
yeah.
With the customer end. How do you know that the customer feedback goes into training the models to become better?
Oh, yeah, so I didn't have time to show you in the demo, but you can actually test it out. We have a tester UI where you can enter all kinds of random utterances and see how the bot performs. And if it's a valid utterance, you can add that to the training corpus, retrain, and the bot will recognize that phrase or similar phrases in the future. I mean, you do it almost in real time. As you're building it, the nice thing about the bot is that it's very interactive in real time. You can test it right away. It's very...
okay, it self-trains itself.
Yeah. Well, to clarify, the models are pre-defined. All you're doing is supplying it example data, training data. Think of it that way. So there's no, yeah, you don't need a PhD.
There is no data transfer to the back end and
exactly.
retraining.
All happens behind the scenes, black box. You don't have to worry about it. You know, you added samples, utterances, and you do the training. It takes a few seconds, and then you try, you know, more utterances, and you iterate. The ideal is this, and many of our customers actually have real chat history logs, right? So what you do is the vast majority of them is not useful data. It might be chit chat or whatever, but you can pull from the log real utterances that map to like maybe these check balances, and you add that to the training corpus because that's what real customers are saying. To the extent you have a lot of that, then your bot's going to perform pretty well out of the box, but it doesn't even have to, because you know over time you'll add utterances that they should have gotten and missed.
Okay, okay.
It literally takes seconds, if not minutes, to retrain the bot, right? Depending on, yeah, it's not very long.
Okay, so it's just the new examples being recycled into the
I'm
bot.
sorry?
It's the new examples of random, okay.
Yeah.
Okay, thank you.
Yeah. But to be clear, it's complex behind the scenes. You know, those of you doing machine learning, if you're taking these courses, you know, the problems are very narrow. So for doing real commercial, there's a whole pipeline of process that you go through. And in that pipeline, there are multiple algorithms that you're using, right? You have data coming in and you have a prediction coming out. In between, it's really an ensemble of a lot of things happening behind the scenes. Optimized for this kind of use case, right? So again, yeah, there isn't a vanilla machine learning model for chatbots. There's no such thing. Right? It has to be tuned for use cases. Ours is, you know, enterprise type use cases. Yeah.
We have a next question here.
Yes.
So your target customer, is it the IT department or is it just a regular customer?
That's a great question. You know, what I'm finding is that it's early days. You know, our products have been commercially available since October. Early days, but right now, I'd say it's 70-30. 70 business line of business, business people, 30 technology. Yeah.
Okay. So do you have some sort, you know how you, when you train the system, if you type in the wrong sentence, it might
I'm sorry, I'm having trouble.
When you train the system and you type in and you enter the wrong sentence, it might just kind of confuse the bot a little bit. Do you have any system that essentially give you a tree map of some sort that say you enter this and there's 5 different intents that it maps to and probability, and how do you adjust them? Kind of like a
you have
testing
full
framework.
control of all of that stuff. But in terms of entering an utterance that it trips up, you decide whether that you should have gotten it or not, or should have been tripped up. And you also control how the bot should perform when you step off the yellow brick road, right? And so a good practice is this. When the user first engages with the bot, right, during that day or that hour, the bot should introduce itself, say, hi, I can help you with the following. Tell them what the yellow brick road is, right? So they don't think, oh, you know, I want to go do this other thing that you can't yet handle. So set that expectation, and then as the user engages with the bot, they still step off the yellow brick road. It's up to you, the enterprise customer, how do you want the bot to behave? Do you want to give them the option to speak to a human? Or do you want the bot to say, please try again? How many times do you want to have the bot try again? And then if that fails, what do you want to do after that, right? Maybe the bot says, okay, just to remind you, I can only do these things today. I'm working on being better, right, and all that. So yeah, you have full control on how the bot should behave when the user steps off the yellow brick road. Yeah.
Thanks, Dan. I think we'll just take 2 quick questions, and then we'll move to our second speaker.
Hi. Thanks, Dan. This presentation, I think, provides a great window into what Oracle provides for the conversational AI. So if I'm a small business customer, can you provide some specifics on how much training data do we need to start with?
Oh, yeah.
For example, like how many test utterances we need per intent, overall training data?
You know, in that prototype I built, the financial bot, you know, for the balances intent, I might have 2 or 3 dozen at most utterances. Different ways to ask how much money do I have in my accounts, right? So, you know, a couple dozen, get up and running really, really quickly. Yeah. Again, your use cases have to be very well defined, right? And the other thing is that you don't want to boil the ocean. the best bots are simple ones, but high value. I have a few customers that just blow me away and say, wow, that's such a simple bot, but it's super high value because it provides both increases in revenue and reduces costs at the same time. We have one that went live in December in Australia.
So we'll just take the last question, Dan, and then the second presentation, and then we'll have more Q&A later on.
So I love the demos. My question is, how many languages does it support? So it was nice to see that it understands Chinese.
Yeah.
How many other languages do you have?
Dozens of languages. No, we're always working to expand the language support that we have, but yeah, it's in the dozens and expanding. And like any good enterprise or product management team, we'll prioritize based on market opportunity, customers, because we can't do everything at once.
Thank you so much, Dan.
Thank you so much.
Hi, my name is Karan Hairapjan. I work at the H2o as a data scientist, and I'll just talk about H2o and what we do and how we approach the machine learning and AI in general. So I don't know if you've heard about H2o, but it's a small startup company. H2o was established in 2012, had a recent Series C in November of 2017. What H2o does, it builds open source machine learning products. So there's a couple of products that H2o is working on, and of course it's its core product, which is the open source machine learning engine. And we also have sparkling water and H2o for GPU, so our own implementations of the core machine learning algorithms to be able to run on a GPU and also take advantage of the Spark environment and working with Spark. And also we have recently created a product called Driverless AI, which tries to automate machine learning. And the goal for it is to democratize AI. So we use AI to do AI. About the company, we have about 100 employees. Most of them are distributed systems engineers who are great at building machine learning tools, world-class visualization designers, and we also have largest number of Kaggle Grandmasters working for us. We have 3 main offices in Mountain View, London, and Prague. So recently, H2o was named as a leader in Gartner Magic Quadrant for data science and machine learning. And one of the key, so if you look here, this is where H2o is. And one of the things is that it has the leadership in most completeness of its vision. It's open source company. We nourish the open source community, and that's one of the reasons that over the years it has a huge amount of adoption. So if you look at it, most of at least half of the Fortune 500 companies use H2o, around 12,000 companies and over 150,000 data scientists or analytics professionals use H2o for building machine learning models. So, about H2o products. So the H2o's core product is, as I mentioned, in-memory distributed machine learning algorithm. So what it is it's designed to be as scalable as possible to meet all of the enterprise needs. We also have Sparkling Water, which is our open source engine integration of our open source engine with Spark. And we recently started building some of our greatest algos to be able to run on a GPU. So H2o for GPU is our library to do really fast machine learning on the GPUs. So those are our open source products. They are Apache version 2 licensed. So that's one of the reasons of quick and high number of adoption. It's basically been built for data scientists and trying to by data scientists also, and we really well understand the pain points of building and deploying machine learning models. So we try to solve some of those difficulties and to make it as easy as possible. And in addition to that, we have Driverless AI, which is our commercial product, and it is built for all type of users that would like to build machine learning algorithms that do understand the process, are familiar with machine learning algorithms, or are on more business size, but still will like take advantage of building smart applications. So I'll quickly give you a little bit of overview of classes of machine learning algorithms and what H2o has implemented within each of those classes. So the first class is regression algorithms. So something like if you'd like to predict, the spend of the customers, or on a business side, if someone wants to predict the number of the parts they need to buy for their manufacturing supply line. So H2o has the specific algorithms that are targeting for regression type of the problems, and those are general linearist models, random forest, gradient boosting, neural networks, and also stacked ensemble. We also have a set of classification algorithms which are trying to answer yes or no type of the questions. If a specific customer will churn within next month or next year or next 6 months within any of the time frames. And these are more probabilistic models that will give you also the probability of specific customer churning or not. So again, here is the list of the algorithms that H2o Core has implemented that can do classification problems, and these are on an open source library. We also have a class of unsupervised learning algorithms. Some of them are clustering algorithms, where you actually want to identify a group of the customers that have such similar patterns. For example, if you have customers that you want to understand who have similar spending habits, given their data, you can cluster them in as groups. There's also unsupervised learning is also very much used in feature extraction. So algorithms like principal component analysis, generalized low rank models, auto-encoders, word2vec specifically for applying to text and natural language. And also we have a set of algorithms that can be used for anomaly detection or finding an outliers in your data set. As again, those are principal component analysis, auto-encoders, and again, generalized low-rank models will work. So this is just a brief overview of some of the machine learning algorithms that H2o we have been building for years. And here I have a diagram which basically designs a simplified model of a typical machine learning workflow. So what you have, or enterprise organizations have, is usually multiple data sources that you would like to combine of them. So once you combine all of the data integration processes, and you can create a data set that you would like to answer a specific question or build a smarter application, you have to do a lot of transformation. So in this step, the data transformation, cleaning, sanity checks, all of those, it's an iterative process in machine learning workflow. Once you do that, you get basically your modeling table, which is all your features or variables or dependent variables, and your target is your independent variable, is the thing that you are trying to predict. And after you have that modeling table, you go through another iterative step, which is your model building step. You iterate on, try out different algorithms, different models, different hyperparameters. There's things like stacking, ensembling multiple models, and then finally you arrive to a model that you think is good enough, that meets your accuracy or any other metric that you're measuring your success rate with, and from there on you have to think about deploying it. So this is a typical machine learning workflow, and those iterative items would take most of the time and consume most of the time, and actually require a lot of expertise, and by expertise by doing and by experience. So one of the things that H2o tries to do is also be able to simplify these iterative processes. So let me kind of explain how this works. So our core product is an open source, in-memory AI engine, basically. We have parallelized and distributed algorithms that have been built in collaboration with scientific researchers from Stanford University and who are there, spent all their life developing machine learning algorithms. And we have been working in conjunction with them to develop best-of-the-class implementation of those algorithms. Some of them are GLMs, random forests, and ensemble methods, GBM, and deep learning algorithms. H2o core libraries have been built in Java, and they're basically great to be able to deploy in any environment where you can run a Java virtual machine. It's a very lightweight library, and it's very easy to install. We also build wrappers for our Java library to be able to access R or Python or any other users the ability to code and use H2o libraries. And one of the advantages of H2o algorithms is that they are very scalable, as I mentioned, so you don't actually have to narrow down or sample your data. You can use everything that you have and model on your whole set of the data. So we do believe that more data and better models will actually help you to build better predictions and smarter applications. So how it works? So if you have multi-nodes instance and you have your Hadoop distribution running on a cluster, what you do is you can launch this H2o, distributed H2o in memory on all of your nodes, and H2o will be able to connect to your existing data sources and be able to take advantage of the data and be able to start building models immediately on top of your distributed system. So just kind of summarize, it's an open source product. It works well with all the with the big data ecosystems. It has a flexible interfaces. Yes. Go ahead.
So you mentioned it supports Java, which is great to see because a lot of the machine learning libraries, they are for Python developers. And I'm wondering how is this different than deep learning 4J library?
Well, first of all, deep learning 4J library is only focused on deep learning. H2o has a much larger number of algorithms than just the deep learning algorithms. That's one of the things. And I actually don't really know much about the deep learning 4J otherwise. But we don't focus on specific set of the algorithms. As I mentioned, we have the whole class of algorithms from linear models to unsupervised models to clustering algorithms to take advantages. There's no free hash theorem. So every problem, every data set requires its own approach, its own algorithm to be able to solve. And again, yeah, it's been written in Java completely, and the rest of our APIs are just interfaces to be able to interact with the core Java underneath in the backend, the Java algorithms. Yes?
Yeah, you're not actually a Java library, you're a Java process, correct?
We are a Java library. Everything has been written in Java completely. It's just a jar file that you launch to be able to access, yes. Yeah, so our algorithms are very fast and very well built, and they scale as with your hardware. So you have more data, you need more compute performance. Just add more nodes and more hardware to it, and we'll be able to scale as quickly as your hardware does. One of the things that H2o has been built with the enterprise customers in mind. So one of the challenges when you use conventional libraries, machine learning libraries, let's say in Python, is you write it, you train a model, I don't know, spend whatever time it requires, but then after that you need to be able to deploy it. That's one of the difficulties. How do you take and productionize a machine learning model, and how do you deploy it? So that's one of the reasons actually we've decided to build our library in Java, because anywhere that you have wherever you can run a JVM, our models are able to be able to deploy it very easily. So for that specific purpose, we actually output, once the model is being built and trained, we output 2 model artifacts. One of them we call Pojo and Mojo. The Pojo is a plain old Java object. So it's a binary in a Java binary that you can just deploy it anywhere you want. It's your basically scoring engine. And Mojo is model optimized Java object. It's still a Java binary, but it's been substantially optimized with the speed and throughput in mind. As I mentioned, we already started building some of the algorithms for the GPUs. And it also, we have integrated H2o on largest cloud providers. So you can actually, it's already on Microsoft Azure, on AWS, and then on Google Cloud. So it's already, you can deploy them, and it's pre-configured instances where you can train the models directly on the cloud. Okay, our most recent product is Driverless Ai. This is one of the non-commercial, it's a commercial, not open source product, and it designs to help data scientists, mathematicians, or users who don't have machine learning background to be able to do, to build machine learning models and be able to predict their problems and build smarter applications. It's basically AI to do AI. That's what Driverless AI is. And it's very simple to use. And it's been designed to automate the whole process. Not only your model building, but also your feature engineering, your data ingestion, your training process, and also the deployment process. So as I mentioned, if we come back to the original graphic here, the typical machine learning workflow is you have all this data integration, but then you have all these iterative processes. So this is the area that's shaded in gray is what Driverless AI is trying to automate. And this is, I just got this definition from the Wikipedia, and the secret of Driverless AI in general is this feature engineering capability, which is the most time-consuming part of building machine learning models. And just if you look at the Wikipedia page for feature engineering, it describes how the process learns and how it's used for machine learning, but it also explains that it's a quote by Andrew Ng saying that coming up with features is difficult, time-consuming, requires expert knowledge, which applied machine learning is basically feature engineering. So what we really try to do is automate this. But we understand that for each of those problems, depending on what kind of data you have or what kind of problem you are trying to answer, this feature engineering process is very different. And it requires a lot of domain expertise in addition of knowing of machine learning techniques. So H2o actually employs a large number of Kaggle data scientists and grandmasters who were able to come up with these recipes that, depending on a domain, automate this machine learning process and are able to create models that actually succeed in a real world life. So for example, one of the key aspects is having better accuracy for your models. So what we do is periodically run Kaggle, take the data from the Kaggle competitions and try it out using Driverless AI. And what you can see here is a few of those data sets. So for example, training the models for Driverless AI, we're able to achieve top 1% in a Kaggle BNP Paribas Kaggle competition. And similarly, top 5% in an Amazon Kaggle competition. So to achieve this kind of results, it takes Kaggle grandmasters weeks to months to be able to come up, to tailor their models, to do all the feature engineering steps, to ensemble all of those models. While these are able to achieve you can achieve the same kind of results using Driverless AI within just an afternoon. And another key focus for H2o and Driverless AI in general is to be able to not build a black box model, but in addition to be able to build transparent models. A lot of the fields are regulated, and we also, in any of the, independent of the field, what we want to do is be able to understand why this machine learning model is predicting something and how it's going to behave in a certain situation. So we are building tools to be able to interpret all of those models that we're building and to be able to understand the behavior of a model and not treat it as a black box. So basically gaining the confidence before deploying any of the models. So let me quickly give you a short demo of how this works in general. So basically this is the interface of Driverless AI. I have some preloaded data sets here, but I'm just going to show how easy it is to load a data set. So that you just click and add the data set. There's my local file system, my HDFS system, if I'm connected to it, and an Amazon S3 bucket. I have some data sets here, an Amazon S3 bucket here. I'm going to load a credit card data set. This is a public data set available on Kaggle or other websites. And the goal of this data set is to predict if the customer is going to default on their credit card payment in the next month or so. So I just loaded that data set, and here I have is just click for actions. What I can do is visualize the data and look at the column by column, try to see if there are outliers or anything, or I can just do predict. It opens up a simple screen interface, kind of summarizes my data here. What I have is 24,000 rows in 25 columns or features. An option to select if I want to ignore any of the column or if I can supply an external validation or test sets. But then I want to select the target that I'm trying to predict. So here, we have some of the columns, all of the columns here. And the goal, as I mentioned, is to predict if the customer will default on their credit card payment for next month. So I just selected that column. And what it did, it completely identified that there's 2 unique values, which is 0 and 1. Either the customer will default or not default. It calculated the number of the rows. And then it suggested me, so we have three dials here. It suggested me some defaults here. Which is accuracy, time, and interpretability. Basically, these are the 3 things that the user should customize. Is the accuracy their main priority? They want a model which is as accurate as possible. If they are limited in time, maybe it's running on a special machine that they are limited on time to train, or just they want a quick model. And then the interpretability level of the model. More complex models are more difficult to interpret, so you can adjust any of those dials. So let's say I'm concerned with the accuracy the most. I select the accuracy level 10, and I don't care about the time. I can adjust any of those, but I do want to be able to interpret. I also can select my own metric that I think is appropriate for measuring the success of the model, or I can let the machine Driverless AI select it for me based on the type of the problem it is. So this is a classification problem, so it suggested me appropriate metrics to measure the performance of a classification model. I'm just going to go with an accuracy here. And then I just click Launch an Experiment. So once I click the Launch Experiment, it will start playing it. So first of all, it gave me a notification here. It says, if you can see it, it says automatically dropping ID columns. So ID columns is not a very good idea to use for training machine learning models because it basically introduces bias on a customer basis. So what you really want to do is be able to predict independent, try to build a robust model independent of the person and trying to estimate the default rates. So you can see here, it's actually a little bit of crowded screen. So this is the summary of the data set as similar to the previous screen. This is the basically percentage of completeness, the iteration level, and how much time it's going to take to complete building the model, the settings that we inputted. And here we can see its performance. So as iterations will go on, the model will try different feature engineering steps, build different types of the models, and show the performance there, and always pick the best level of it, the best model, and try to minimize the metric that we selected. In this case, accuracy. So it will try to maximize. More is better for accuracy. It will try to maximize the accuracy based on different feature transformations. And here we show a standard ROC curve with the area under the curve being 0.770. So I won't wait for the model to finish here, but I did run the same thing a little bit earlier. So this one is running. So I have the experiments here, all my previous experiments that I did here. So I click the experiments here. This one is the one that we are running right now. I can go always back to it. But I also have one that just finished. So if I click on it, what we can see is basically the performance. So the accuracy kept improving slightly based on the models, based on a different feature transformation. Here we can see the variable importance, which of the variables were playing the most role, and what kind of transformations it did for it. And we also have a complete, so transparency is a key here. So we have a detailed log here, which you can see tells you every single step it did take and every single feature transformation it did and how much did it improve. And then there is the final model summary here. From here on, we have a few more options. We have here interpret the model and to come to the interpretation screen. But we also do a score on another data set, or we can download the scoring package and use that to be able to deploy this model. I also have a screen here for the interpretation for the same model here. So if we click the machine learning interpretability for this specific model, what we can see here is basically 4 different plots. The first one is the K-line plot. So this is the predictions. This is every single data point we have in a file, and the predictions, they are sorted by the probability of being default. That's why it's a nice and growing curve. If I click on any one of those points, it will be an actual customer. Here is the feature importance chart, and here is a surrogate decision tree, which tries to mimic our final, more complicated model, which is an ensemble of different models in a very shallow decision tree, and try to understand, to explain the logic and how it got to each of the decisions. And here we have a partial dependence plus with sensitivity analysis. So let me click on any of those points here. If we click on any of those points here, it specifically shows the feature importance for not only for the general, the global feature importance for the model, but actually for this specific customer. And we can see for this specific customer, the feature importance looks slightly differently than for the global model. And same for the decision tree, and the same for the sensitivity analysis. We also took it to the next level, and we generate reason codes, which allow in a regulated field allowed for the auditors to be able to audit the models. So if I click explanations here, it will actually create reason codes which are in natural language, and you can see that the pay amount by 4, the pay 0 amount variable had a value of 4 specifically, which increased the probability of the default for this customer by 0.42. So these are reason codes that can actually be archived and documented and used for decision making. Basically, we do have 3 screens here. One of them is the data sets, one of them is the experiments, and then the interpretability screen that allows you to audit the models. So I'll stop here and ask if you have any questions. Yes?
So is this scalable? You showed a small model.
Oh yeah, so I forgot to mention that. So we take advantage currently for GPUs. What we see is that the most beneficial and the most efficient way to train such models where you would take multiple iterations and on the same data and multiple transformations is via GPUs. We get the greatest speed advantages on that. So if I look at the experiment that I was running, oh, this one is done already. I'll launch a new one. So these are running on a GPUs. So it is scalable within the same node. So if you have multiple GPUs, it will take advantage of every single GPU that you have. But it's not multi-node yet. In a training stage. On a deployment stage, we offer you a Python package that you can just deploy it on a scalable on as many nodes as you want. So the training part. So you can see here, I have the GPU usage here, and this is not a very large data set, so my GPUs are not very occupied. It's only 24,000 rows, but it will take and distribute it across my GPUs within a single node. Yes? Sorry, can I? Yeah. Sorry? Can you repeat that? Yeah.
How does your system deal with optimization bias?
Optimization bias? Can you?
So, because if you keep training on the same data set over and over again,
yeah, so what we do is the method that we use is called reusable holdout. So we use a reusable holdout for that, and we do internal splits to be able to train on that.
Okay, thanks.
It's actually a recent paper that's published in Science, the reusable holdout by Google, that actually approaches the same problem.
I just want to go through something very basic. So you have all these algorithms that can be used, but if I'm doing something, let's just say keep it really simple. I do essentially, write, word count for MapReduce, and I get that working, in the single system. Then I can then deploy that whole thing against a local cluster or into AWS. Is that the case? That's what I think I'm hearing.
For the driverless AI or H2o core, because these
for the community one. So if I just do something like word count and something, and I can use the other algorithms as well to do different things, now can I deploy that, and it will now scale out?
Yeah, so if you have trained any model, am I understanding you right? So you have a model.
I'm asking, trying a really simple question, just a hello world example. I do word count in MapReduce, right?
Word count.
Yeah, really basic stuff.
Yeah.
And then, I've got that working my single node, but now that's all it is. But I now want to deploy it, say, in AWS.
Yeah.
Can I do that using the Community Edition? It will take care of that whole thing?
Yes.
Okay, that's...
So, yeah, it's just it's going to output you an artifact, which is just a Java binary. You can run it in anywhere. You can have a JVM.
Okay, so I can deploy that. So you handle the deployment, so I can work locally and then deploy into AWS.
Well, you have to first train a model, right? So,
yeah.
And once you train that model, yeah, we'll give you an artifact file that you can deploy it anywhere you want and on as many nodes or as scalable as you want. And keep scaling it.
But in something in terms of word count, it's not really a model. I'm just doing some MapReduce work in that case. Can I still deploy that the same way?
Well, if you use H2o to do that,
yes.
Well, H2o has a core algorithm. I mean, there is some data munging capability, so you can write some query-like things to do that. No, but what we give you is an artifact for the model. So you do have to train a model before we give you that artifact.
Okay, I'll take this offline and ask you later.
Yes.
Then. Thank you.
I want to ask about the underlying model you are using. If TensorFlow used here or another Oracle-related model.
Oh, for the driverless AI?
Yeah.
Okay, so there is single. So what everything is based is, first of all, is based on open source products, and mostly that what H2o has been developing as an open source product. So basically this takes all our open source products and our own expertise of this idea of the recipes and puts them all together and tries to automate that. To answer us more specifically, what this uses is clustering algorithms, for example, SVD, truncated SVD more specifically. We use some algorithms, some simple neural networks for embeddings and learning some embeddings. And the main algorithm that does the models is the XGBoost underneath it. The XGBoost for GPU, which H2o is the largest computer due to the GPU implementation of XGBoost.
Any other questions?
Yes.
Okay, my question is simple. Is there any limitation or you want to be improved in the future?
Oh, absolutely. We keep adding features on it. Our actually average release cycle currently is 2 weeks. So every 2 weeks we can basically we make improvements to this and release it. Right now we are effortlessly working on time series capability where we have sequential data. We already do have ability to handle text features, so unstructured text, and we just keep improving on it too. We actually have a roadmap, a huge roadmap that's for the design and making this completely better and better, and it includes anything from being able, for example, right now one of the limitations is we don't handle image data. That's coming in the future, and some of the things we always have an idea of how we can improve it. And by our culture, H2o has been very much affected by the open source and by the community in general. It's a community-driven company, so we really well listen to our users and take their input in how they see what they need and how they would like to, keep making us changes and improving the product. Yes.
Is the performance same or better than Spark MLlib?
Well, there's public benchmarks. There's public benchmarks which actually benchmark our H2o's algorithms to Spark MLlib's algorithms, and it comes down. It's very much dependent on the shape of the data, on the type of the data, on a problem you are trying to solve, but we're very happy with our performance, even in comparison with the MLlib. So I could refer you to some of the publicly available benchmarks that's done independently, but none of the, anyone involved with H2o or Spark MLlib, it shows in some cases, in which cases which one behaves better. In most cases, we do really well. So that's, one of the things also is that, it's actually a pretty small team that works on Spark ML, but we're hired, it's a commercial company with 100 people that actually main focus is this. So it takes much more, we can put much more effort into it too. Yes. Sure. Okay.
You indicated that you do a lot of feature identification. So for example, like one hot exploding, you'll take care of that for me?
Yeah, so, sorry. One hot encoding, that's what you guess. Yeah. So yeah, the feature engineering step that we do is actually much more sophisticated techniques than one hot encoding. We actually found that one hot encoding works in a very, very limited number of the cases. Right. So we have a huge, what we call transformers. So one hot encoding is also a transformer, which transform to your data to a different representation. So we have a huge list of transformers, and we use genetic algos to decide which transformers to use, which of your features, and to be able to represent in a more understandable way for the model, for the algorithm to be able to consume it. So yeah, absolutely, that's one of the beauties of driverless AI.
Yeah,
and does it really well, believe me.
Expanding enumerated classes would be just really super helpful. The second one I had is, so this looks like a really great way for me to build a starter model for some of my smaller problems, or if I have a huge problem, I shouldn't say starter, I apologize, let me rephrase. This looks like a great way for me to start and build my first models for my less complex models. If I have a model which has on the order of 20, 30,000 features, and then many, many, many rows, where I'm going to need to do much more levels of complexity and much richer models, does this let me export and then edit or view or extract the generated model in any way?
Yeah, so it's twofold, your question. In terms of number of features, it is limited to first of all, it is limited to your GPU memory, because all of the algos and all of the implementation basically rely on your GPU to be able to do this, because this would take huge amounts of time on a CPU to try out everything iteratively and systematically. So having huge number of columns and same number, large number of the rows is a difficulty. And that's why we're trying to scale to, even though within single node we can take advantage of every single GPU, but we're trying to do multi-node, multi-GPU now. And as we build that functionality more and more larger data sets you can consume. And in a hardware believer that you shouldn't sample, you shouldn't narrow down, just throw the whole data. That has been H2o's thing for 5-6 years now. That's the first part. If you build a model, no matter the complexity of the model, we export you everything that you need about the model, completely transparent with all of the transformations. So if you have a incoming data set or scoring engine, or somehow we have new data coming and you need to retrain, or just transform using every single transformation that was done on the data set, you will have everything access to that as an API for that. Thank you. Any other questions? Well, thank you. If you want to learn more about H2o, it's just simple h2o.ai, and you can get a trial version for driverless AI at h2o.ai/driverless AI here. Thank you.